Welcome to this video about using Ceph storage. In our previous video, we set up a 3-node Ceph cluster on Google Compute Engine virtual machines. Today, we're going to put that cluster to work and show you how distributed storage actually functions. Let me start with a quick tour of our setup. We have 3 virtual machines in our cluster, plus this management and administrative node that we're working on right now. Each of these VMs has 2 disks that are configured as OSDs, which stands for Object Storage Daemons. These OSDs are the workhorses of our storage system. Before we can save any data to our cluster, we need to prepare it properly. The first step is to create what's called a pool. A pool is a logical partition where we organize our data. We'll use the pool create command and specify that we want an RBD type pool. RBD stands for RADOS Block Device, which allows us to create virtual block storage similar to what you might know from AWS's Elastic Block Storage or EBS. When creating this pool, we also need to specify the number of placement groups. For a small cluster like ours, 32 placement groups is a good starting point. Placement groups help Ceph distribute and manage data across the cluster efficiently. Great, our pool is now created. Next, we need to initialize this pool so we can hold RBD images. We'll use the RBD command line interface for this. This initialization step prepares the pool to store our virtual disk images. Now let's create our first image, which is essentially a virtual disk. We'll make it 10 gigabytes in size and call it My Block Device. After creating it, it's always good practice to run the RBD ls command to verify that our image was created successfully. And there it is, our block device appears in the list. The next step is to make this virtual disk available to the operating system of our VM. We do this using the RBD map command. When we run this command, a new block device appears in our system's list of available disks. We now have a 10 gigabyte disk that's backed by our distributed Ceph cluster. Before we can use this disk, we need to format it with a file system. We'll use the standard Linux mkfs ext4 command to create an ext4 file system. If you get an error about a missing package, you can fix it by running sudo apt update followed by apt install e2fs programs. In our case, it turns out the package was already installed. We just need to run the command with sudo privileges. Now that we have a formatted file system on our disk, we need to mount it to make it accessible. Let's create a mount point at mnt ceph storage and mount our new disk there. Once mounted, we can run the df command to confirm that we have roughly 10 gigabytes of available space. To test that everything is working, let's create a simple test file in our mounted storage. We'll call it test file and verify that it's been created successfully. Perfect, our file is there and our storage is working. Let me recap what we've accomplished here. We've created network-based block storage, which is open source and distributed, similar to commercial solutions like AWS EBS. If we check the Ceph dashboard, we can see our RBD pool and the 10 gigabyte image we created, both showing as online and healthy. With just a handful of straightforward commands, we've transformed our Ceph cluster into reliable, distributed block storage. The key steps were pool creation, RBD initialization, image creation, mapping the image to our system, formatting it with a file system, and finally mounting it for use. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. If you have any questions, please post them in the comments section and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy responsibly.